All right, chapter 8.5, the dot product. Basically what we're finding the product of two vectors, and we call it the dot product. So here's the dot product right here. Take vector v times vector w equals a1 times a2 plus b1 times b2. Simple formula for multiplying vectors. All right, let's take a look at an example. Here we have vector v, 2i minus 3j, where 2 is a1. Well, it depends on the order, so let me back up for a minute. And vector w is 5i plus 3j. So if we're multiplying vector v times vector w, then vector v will have the a1, b1. And I put those over here, a1 and b1. And then vector w, since it's second, will be a2 and b2 right over here. Okay? So we just plug these numbers into this formula and we get 1. Now if we switch it around, okay, vector w times vector v, then vector w will have the a1 and b1, okay, and there they are. I don't know if this is showing up, okay, a1 and b1, so that's vector w, and then vector v will have the a2 and b2. Plugging it in, notice it gives us the same answer. So notice that v times w is the same as w times v. That is the commutative property of the dot product and multiplication. Okay, next one. Take vector v times itself. So we're going to use number 2 as a1 and a2. And we're going to use negative 3 as b1 and b2. Okay, so here's a1 and a2, same number, b1 and b2, same number. Plug them into the formula, and we have a dot product of 13. Okay, continuing on, this is starred. Ignore this star. This is starred because this is probably going to be on your quiz. So make sure you know what vector w times vector w equals. Okay, quiz question. Okay, the magnitude of vector v, we use that formula that we learned in the last section, the square root of a1 squared plus b1 squared, and that's going to be equal to the square root of 13, the magnitude of vector v. Okay, again, another possible quiz question. Possible vector w, what does that equal? Okay, something to keep in mind. Since the dot product is a real number, in other words a scalar, it's sometimes referred to as the scalar product. Again, another possible quiz question. Possible. Now, properties of the dot product are found on page 620 and 621. Commutative property, distributive property, multiplying vector v times vector v is equal to the magnitude of vector v squared, and 0 times vector v is equal to 0. You could look at those more in the textbook. Okay? All right, let's turn the page here. The next thing we're going to look at is finding the angle between two vectors. So for example, if I have vector v, and it goes something like this. We'll call that vector v. And we have vector u, and it has the same initial point. So we have the initial point, we have the terminal point, and the initial points are the same for both of these vectors. And then we have vector u minus v. U minus v will give us this vector. Notice we have a triangle. And let's go ahead and label this vertice right here, vertice A. And we'll label this angle right here, theta. And I wrote this backwards. It should, u minus v is going to be backwards, this direction. Okay, so how to find the angle between two vectors? Okay, so in order to find theta, we have a triangle. Okay, we could, if we knew the information, what this vector is, and then calculate u minus v, we can use the law of cosines to find theta. Law of cosines. So what we want to do is we want to find the magnitude of vector v. We want to find the magnitude of vector u, the magnitude of vector u minus v, and then theta is the included angle here. So if you'll recall from the law of cosines, so if this was A, this would be opposite A, little a. And so we would have, if we looked at it as that being little a, and recall that a squared is equal to b squared plus c squared minus 2 times bc times the cosine of the angle. Remember that this angle is opposite this side. So this angle is opposite this side here. So plugging this in, we have the magnitude of u minus v, that corresponds to side A, because it's across from this vertice, is equal to, okay, now it does not matter which one we use here, so let's go ahead and make b this side over here. So u squared, the magnitude of u squared plus the magnitude of v squared minus 2 times the magnitude of u times the magnitude of v times the cosine of theta. And that's how we would find theta. We would solve this for theta. Okay, and it's a squared, so I forgot to square that magnitude right there. All right, so let's go ahead and multiply this out. Since we're squaring a magnitude, okay, take a look at, I'll show you in the book. Hopefully you're following along in the book. But this is a very important, what we're going to be using right now. When we have a magnitude squared, then we take that vector times itself. When we have a magnitude squared, we take that vector inside times itself. Okay? So we're going to have u minus v, okay, times u minus v equals, using that same property, let me write it over here, v times v equals the magnitude of v squared. So we're going from it looking like this to looking like this. So this would be u times u plus v times v, okay, minus 2, and then we'll rewrite this part over here. Okay. All right, we're going to go ahead and multiply these together. we're going to go ahead, I'm going to go ahead and just use the distributive property twice on this. So I'm going to take this first term and multiply times both of these. So u times u, and then it's going to be u times negative v. So that's going to be minus u times v. Okay? And then take the second term, that's going to be negative v times u, so minus v times u. And then negative v times negative v is positive v, so it's going to be v times v. Because a negative times a negative is a positive, okay? And v times v is right there, okay? Okay, just do a little combining here. We got u times u, okay? Plus, I'm going to move the v times v over here. And then a negative uv and a negative uv is minus 2uv. Okay? Okay, next thing I'm going to do, I'm going to bring down the right side back down. So we got u times u plus v times v minus 2 magnitude of u times the magnitude of v times the cosine of theta. Okay? And so notice if I subtract the u times u from both sides, they cancel. And let's take a look at what's next. What else could we do? Looks like we can cancel out if I subtract the v times v from both sides. Okay. Now remember, we're just kind of simplifying this right now. We got a negative 2 on both sides, so we could divide both sides by negative 2. So we're going to have u times v is equal to the magnitude of u times the magnitude of v times the cosine of theta. Okay? Now, we want to solve for the cosine of theta, so we're going to divide both sides by this. The magnitude of u times the magnitude of v on both sides. Okay, so that cancels out. So here's your theorem for finding theta. The cosine of theta is equal to u times v, vector u times vector v. So you got your dot product. Oops, I got to move it up. Sorry about that. So you got your dot product on top. Simple. We know how to do a dot product. Divided by the magnitude of u, which we know how to find, times the magnitude of v, which we know how to find. So what we have here is a very easy, workable formula for finding the angle, where we don't have to do this long process. We can just go straight to this theorem and use this theorem to find theta. Okay? And this theorem is found on page 621. And this process is also found on page 621. Okay, let's take a look at an example. Okay, so I'm going to go kind of quick here, but in order to find the theta, we need to do the dot product with these two vectors, and we have to find the two magnitudes. All right, since I have less than a minute, here's your dot product using the formula. Here's your magnitude of u. Here's your magnitude of v. And now we're going to plug it in to this formula right here. Okay, I plugged in the dot product into the numerator, the magnitude of u times the magnitude of v into the denominator. It comes out to this as a decimal. And don't forget, to find theta, you do the inverse cosine of both sides. And if you're in degrees, we get 105 degrees. Now for your assignments. Okay, page 626, 7 through 17, we're doing the odds, and we're only going to do part A and B. This will be due on Monday. Have a great night. See you tomorrow.